Welcome to Programming in Modern C++. We are in week 4 and we are going to discuss module 19. In the last module 18, we started discussing about operator overloading. That is how to define operator functions for user defined types, so that we can build complete algebra with our user defined types, much in the same way the algebra is available for built in types like int, like double and so on. We have looked at overloading operators using global functions and member functions of classes, and we have also outlined the semantics for overloading binary and unary operators. Building up further on that, we will now try to understand overloading all types of operators for a user defined type or a class, and particularly focus on the aspect of overloading by friend function and what advantages does that specifically provide. This is the outline, will be available on your left panel. So, a quick recap from the last module. We have 3 options to overload using global function, using member function, or using friend function. So, if A and B are of my type, where my type is some enum, struct or class type, then I could write the operator function, say for operator plus, which takes 2 parameters left and right and returns me the final result. I can use a member function of the my type class, and in that case my operator function takes only one parameter, which is the right argument, because the left argument is the implicit parameter, which is the object on which this operator is being invoked. Doing it with a friend function is very similar, because it is just like another global function, but it is prefixed with the keyword friend, and its prototype is declared within the scope of the class, declaring that this is the friend function. This is what holds for the binary operators. For unary operator, similarly I can have global version with one parameter, member function version with no parameter, or the friend version which is also with one parameter. What is to be noted here, which we saw at that time, is the fact that if the unary operator is prefix or postfix, if it is postfix particularly, we will need to pass we will need to declare it, not pass, declare it with a dummy int parameter. So, equipped with this, let us now look into the issues in operator overloading, and we will present 2 specific cases where we have issues. So, consider a complex class, and we have learned how to overload the operator for 2 complex numbers. So, we have 2 complex numbers, we can overload it like this to get the result. So, actually what we get is D1 dot operator plus, and that takes D2, or it is called as a global function, whatever way it is, it will work. Now, suppose we want to extend that operator so that the complex number can be added to a real number also, that is which has no imaginary part. So, if we have these complex numbers, I want to make this addition, that is D 1 plus 6.2, which actually means 6.2 plus J 0, or 4.2 plus D 2, which means 4.2 plus J 0 to be added to D 2. if I want these also to be valid for my operator plus. Right. Now, we have to see why global function is not good for this and why member operator function cannot also do this and only friend function can achieve this. So, this is the context in terms of which we are trying to refine the operator function. The other context that we will deal with is of the IO operators, streaming operators. So, we have a complex class. So, I want to write these kind of streaming expressions to print or read the complex values. So, we know that C out is a O stream object, we know C in is an I stream object predefined. Again, we show why global function is not good for this purpose, why member function also cannot achieve this task, and we finally show that how friend function will provide a solution. So, two different contexts that we are highlighting here, where our the solution we have looked at so far is not going to extend, and we will see the specific difficulties that we will come up with. So, first let us try to address the first issue, try to extend the operator plus. So, if I have to extend this, then what I can do is I can define using global function. So, since we are looking at three forms, that is d 1 plus d 2 is one form, d 1 plus say 6.7 is another form, 4.2 plus d 2 is another form. So, since we are looking at three forms and you can see that they have different types of the parameters. So, we can overload this operator plus thrice, one for a pair of complex which will work for this, one for a complex and a double which will work for this, and one for a double and a complex which will work for this. Right. This solution apparently will not have any difficulties, and you can try out with these examples and it will work fine. The only difficulty that arises is with the fact that being global function, this will not be able to access the data members of this class. So, I have to make the data members public. The moment I do that, for doing this operator overloading, I have to break the encapsulation that I have created with so much of care. Right. So, this is not a very good approach. Right. And we have also provided explicit. I will talk about explicitly later on, but all that it means that if your constructor is explicit, then it has to be directly called either through this or through new. It cannot be used implicitly for doing a conversion. Okay. So, the global function cannot work because it is breaking the encapsulation. So, that the whole paradigm falls apart. So, let us look at member function. So, as we look at member function, then I have one member function which takes a complex, takes care of d 1 plus d 2. I have another member function which takes a double, which takes care of d 1 plus 6.7. So, the first expression works, the second expression works, but how about the third one? If I have 4.2 plus d 2, I cannot write a member function to do this, because the member function always binds with the left hand side parameter, left parameter. So, 4.2 plus d 2 basically in member function notation means 4.2 dot operator plus d 2, which means that operator plus has to be a member function of the double type, and you know built in types like double cannot let their operators be overloaded. So, this is not going to, this is going to partly work for this. This of course restores the encapsulation. The data members are back to private, but this does not solve the problem, because the third form of the expression is not permissible. So, let us look at using the friend function. So, how does friend help? Friend on one side is like a global function in terms of function call and all that, and it has the ability to access private data member of the class because it is a friend. Right? So, while writing global, if I want to protect the encapsulation and use a global function for working on the class, then I will have to get into all that get set mechanism, lot of extra code has to be written, but with the friend function I do not need to do that. Now, the operators can actually be overloaded either by a global function or by a member function is what we have seen, but the question is, if the left operand is not an object of the class type, then it cannot be overloaded through member function. That is precisely the case we are getting into when we have expression like 4.2 plus d 2. So, to handle such situation, we can make use of the friend. Now, let us say there are two objects d 1 and d 2 of the same class. We cannot overload constant plus d 2 using the member function. However, using friend I can do all three of them, because I could do them with global function. Right? Friend is just, I mean, in this case it is like the global, except that it does not break the encapsulation for everybody. So, the reason is, while computing d 1 plus d 2, the member function d 1 with member function, if I try to do with member function, d 1 calls operator plus and d 2 is an argument. Similarly, for d 1 plus constant we have seen that it calls operator plus and constant is a second argument, but when we have this we cannot do it because the constant cannot call a member function. So, similar analysis will also hold not only when this other mixed parameter is a constant, but when it is an object of a different class, which is what is happening in case of the IO stream also, we will come to that. So, operators like streaming, like relational should be overloaded using the friend function. So, let us try to do that for operator plus. So, now what we do is we have again three overloads, complex complex, complex double, double complex. Instead of global, they are all friend function, the encapsulation is perfectly maintained and all three become correct. Right? I could have done a different solution also, which we will discuss further in a much later module when we talk about casting, is that do not provide these, do not make the constructor explicit and just provide one operator. Mind you, this will also work, but it will work differently. The way it will work is, since d 1 plus d 2 is fine, but when I do say d 1 plus 6.2, 6.2 is a double and what I need as a second argument is a complex. So, it does not match, but what the compiler will see is there a way to construct a complex object from a double? Well, it is there. Therefore, it will construct a temporary double object and call this function. That is a different way the mechanism will work, which is often not very advisable, because then it will be able to possibly cast integer also, right. It depends on what I want to define. When I make the constructor explicit, I actually stop all of these irritating silent conversions from happening, and I exactly know what are the data types that I am going to add through my operator. Right. So, the friend function, friend operator function really provides a good solution. Just as an illustration, take a look at overloading a comparison operator, say equal to operator. So, what am I having? I have included string here because I want to use the string type of the library, and I am defining a class mystr, which is kind of a simple wrapper string for me. right, which just copies takes a C string, copies and makes an object, later on at the time of destruction frees that up. I want to compare a library defined string object and a MyStr object for say equality. So, there are 4 possibilities actually, because there are 2 classes. So, there are 4 ways I may compare. So, one is MyString with MyString, which is these 2 cases. So, I have defined objects MS1, MS2, MS3, which are MyStr objects. SS1, SS2, SS3 are library string object. So, I compare MS1 with MS2, MS1 with MS3. One I have kept equal, another I have kept separate. These 2 are equal, these 2 are separate, just to show that comparison outcome being true and outcome being false both work. So, this will work with the first overload, because both are MyStr. In the second, I have MS1 and SS2, MS1 and SS3. So, it is MyStr and string, MyStr and string. So, the second overload will work and I will have correct response based on that. The third is string and MyStr, that is the third overload. This will work to give result in these 2 cases. All are correct, you can see match, mismatch, match, mismatch. And finally, the fourth possibility is I compare a library string object with a library string object, that is SS1, SS2, SS1, SS3. Now, in this case I am not providing anything here, because my class is not even involved and library has already provided a overloaded comparison equality operator for this string class. So, here it will also work with the comparison operator from the C++ standard library. So, you can see that I can define operators, I can mix operators from other class, obviously with judicious design, and this was possible without breaking the encapsulation or anything by using simply the friend function. So, let me move on to discuss the IO operators, the other issue, the second issue I talked of. So, we want to say create an output streaming operator for complex class. So, that any complex number I have, I should be able to just write this 2 complex number D1, D2. As you know, this will be done first, right, it is left associative, this will be done first, which must return the C out again, because I want to chain, and this will be done next, right. This is so, if I want to, this is the behavior that I get for integer, character, double, these kind of built in types. So, I want that behavior to be present. So, let me see of the 3 options what will be the different signatures of the overloaded function. If I have a global function, then my first operand is this one, which is OStream, is passed on as a reference, because certainly you do not want to copy the entire output stream, and also pass the complex object as a constant reference. This is not to be made const, the OStream reference is not to be made const, because I am going to write to it. So, it is going to get changed, and after I have written, I must get back, after I have written, I must get back the same OStream object. So, that when I do the chaining, this what I have got back will be able to go into the second instance of the operator, right. So, that is the basic style that we will have to maintain, right. Okay. So, this is if we do it by global function. What if we do by a member function of the operator class, member function of the operator class. So, I am sorry, not the operator class, member function of the OStream class that is there in the library. So, the operator now is OStream : operator output. It takes one parameter, which is the complex, the O stream is already there, and it returns the reference to the O stream object, which should be fine. The third option is the other class involved here is my complex class. So, I can make it an operator of the complex class. If I make it the operator of the complex class, so basically the operator will be invoked on this, then the parameter it has to take is the O stream object, and it has to return that O stream object. It has to return the O stream object in every case, right. Okay. Now, let us see what happens in these cases. So, with a global function, if I do it with a global function, if I do it with a global function, then it will work fine, except for the fact that I have to break the encapsulation, the good old problem. So, breaking this encapsulation is not going to be a good thing to do, right. So, global functions are not preferred. So, my next option is to use a member function. Now, let us say it is a member function of what? Suppose it is a member function of the O stream class, which has this signature. Now, this is a perfect solution, but the reason it will not be possible, because as a developer I am not allowed to make changes to my C++ standard library. So, O stream object is a part of O stream class is a part of the C++ standard library. So, I cannot make a change, I cannot add a new operator, overloaded operator for my complex class argument to get this implemented. So, this is technically a possible feasible solution, but this is not allowed according to the rules of the library. Right. So, I have to then look at as a member function, I have to look at as a member function for the complex class. So, then this is the signature that I will have, it is complex : operator output, which takes O stream as an object, as an argument. So, O stream becomes the second argument or the right argument. Therefore, when I want to output this, I have to write it as D output C out, like it gets inverted, which is not neither it is good for streaming. So, if I have to actually I would have liked to write C out, say there are two objects D 1 and D 2, I would like to write this. This is what the built in types write, but here what I will have to write? I will have to write because unless my object D of the complex class come on the left of the operand, I will not be able to invoke this operator and pass the C out to it. So, I have to this is completely unnatural, and then I have another problem is that this operator is left associative, right. So, if I write this and do not do anything, it will try to first execute this instance, which takes too complex and does not make any sense. So, it is not only this, I have to actually put a parenthesis around it. So, while this is the form of the expression for a built in type, my overloaded operator, with my overloaded operator the expression will look something like this, which is really annoying. This is not something that is making the natural extension of the type as I wanted to do. Right. So, the only choice left is to have a friend function. So, now what I do is it is like the global itself, take the O stream and the complex, I stream and the complex, return the O stream for output operator, return the I stream for the input operator, and you can make the encapsulation rein in again, because you have friend functions. And the way you write this operator is very simple. This you have got this A. So, as a friend it can access RE and IM. So, you take RE, you take IM, and I am assuming that to mean it is a complex number, I am writing it in the form of real component plus j imaginary component. So, I stream that to OS. These operators will work according to the respective built-in type. For example, here the output streaming operator for double will work, here the output streaming operator for constant string or string will work, here again the double will work, and so on. So, O stream is now got whatever I have outputted. So, what I will have to do? I will have to give it back as a result. So, I return O stream, which actually comes back as my O stream reference result. So, when I now write C out D1, D2 and chain it, by left associativity this is done first, this goes as OS, this goes as A, and into that C out this is written, and what comes back is again C out. So, the result of this is C out. So, again when the second instance is happening, C out goes in as O stream, D2 goes in an A, and what comes out is again C out, to which I can stream anything else. Right. So, it perfectly falls in order in terms of the syntax of the expression of output. You will not be able to see any difference from the ordinary built-in types. So, the same thing will also hold for the I stream. So, this was about operator overloading. To summarize, here are some general guidelines. So, out of the three options, what will you choose when? Right. So, you can choose a global function when you do not care about encapsulation, it is not a concern. For example, you are trying to write something for a struct in C++, which means there is no hiding, no encapsulation. So, then you can just use global function to keep things simple. You will have to use member function when the left operand is necessarily an object of the same class for which you are overloading the operator. Right? Then you can use a member function. And specifically, there are operators which will have to be member function overloaded as member function, like operator assignment, you have already seen that, operator new, operator array new, operator delete, and so on. They all will have to be necessarily member. So, it is not a generalization that you will always do friend. You will do global if you do not, if you want to keep things simple and do not have encapsulation concern. You will have to do member function if it fundamentally defines the behavior of your class and always will have the left operand as an object of the same class. That is a simple solution. Otherwise, for example, other operators like your increment operator and post increment, pre increment could also be done as member functions. Otherwise, you use friend function for operators like streaming, for relational, and so on. Right. So, this is the basic structuring rule of operator overloading. In terms of semantics, it is good to preserve the natural semantics. For example, if you are overloading operator plus for a say set, then you should do that for union, not for intersection. Right. So, that same sense, similar sense must be prevail. Similarly, usually for parameter passing, follow the usual convention that pass the built-in types by value and the user defined types by constant reference. The return type will decide based on whether you want to have a reference, if what you are returning is an existing object like cout, or whether you will return by value because it did not exist and you are creating, like in operator plus for complex, and so on. So, based on that, choose the return type appropriately. Should consider the effect of casting as well. We will look at this more when we deal with casting operators. And last but not the least is do not overload an operator which you do not need to, that is skip to minimal design, because the more you overload operators, you are adding semantics to your design and it may be confusing for someone who is not well acquainted with your design. So, only add operators that you really need for your class. So, we have talked about several issues of operator overloading, discussed that and particularly highlighted the context and the mechanism by which friend functions can be used for operator overloading to get really nice solution for IO operators and so on. These operator overloading can be used to build algebra for various different types, as we will see more and more. Thank you all very much. Thank you for your attention. I hope this will concludes our discussion on operator overloading. I think you have got a good grasp to that. I will record a tutorial to show you how, using this operator overloading and other features, you can create complex like data type much in the to behave and to lexically, syntactically look very similar to the built in type, and you can get to the creation of the algebra.